All right, let's go do it. So we've looked at our original design. We looked at a slight modification of that design. Let's look at a third modification of that design. I'm using a 4-inch spacing. What does the code tell me I'm allowed to use? Up to some maximum spacing, right? So let's figure out what our maximum spacing is here. One value of the maximum spacing was d over 2. So that's 20 over 2. That's going to be 10 inches. That's the one stirrup in every crack criterion. Another one was AB Fy divided by 50 times the width of the beam. So that's 0.22, 60,000, 50 times 12. So what's that come out to be? 22. And then the third maximum spacing formula is AB Fy divided by 0.75 square root of F prime C times B. Remember, under the square root sign, that's got to be PSI. So what does that third one come out to be? Okay, and so really the maximum spacing is going to end up being the smallest of all these. So the maximum spacing here is 10 inches. Well, the code tells me I'm allowed to use a 10-inch spacing. When I use a 10-inch spacing, I still have to be above my VU diagram. So let's figure out where theoretically I could use a 10-inch spacing. All right? So the first thing to do if I'm gunning towards this 10-inch spacing, the first thing to do is to figure out what VS is with a 10-inch spacing. The VS is AB Fy D divided by 10 inches. So the V sub S, when I'm doing this, comes out to be what? 26.4. Then I'm going to calculate what my total design capacity is at 10 inches. The total design capacity means I include the concrete strength as well as my VS. So 0.75, I think we said before that concrete strength was 30.4. And we just calculated a V sub S at 10 inches. So my VBN, when I'm using a 10-inch spacing, my design capacity is what? 42.6. So I just need to know if this is what I am when I keep a 4-inch spacing. I just need to know where I'm allowed to drop down to so I don't go below the line, the VU line, right? I could be at the VU line. I could be right on it. I just can't be below it. So, really, the question we got to ask ourselves is, where does this VU line become 42.6? Well, sounds like another straight line formula. 42.6 is equal to minus 8. I'm looking for an x distance. I start out at 8. That x distance now comes out to be what? 4.68. That's feet. If I change that into inches by multiplying it by 12, 56.1. Okay, so roughly 56 inches is where I could make that change. If I go past 50, if this is 56, if this is 60 inches out, and I make this change, what's going to happen? I'm going to be okay. As long as I'm past that point when I make the change, I'm going to be okay. Okay? So, more refined design. one at 2. There's my locator stirrup. How many at 4 inches is going to get me 56.1 or further out? Let's see. I think 14 times 4 would put me right at 56. If I add 2 to it, won't that get me out past that point? All right. Then I could be at my 10-inch spacing. And how far can I carry my 10-inch spacing out? Yeah, to 103, to where I don't need stirrups anymore. So let's see, I'm at 2, now I'm at, this is 56 plus 2, I'm at 58 inches. How many 10-inch spacings will get me out to 103? Well, let's see, 4 times 10, 40, that's 98, that's no good. How about 5 times 10? That would put me out at 108. That's past where stirrups aren't needed anymore. So now here's my really refined design. 1 at 2, 14 at 4, 5 at 10, each end. Okay? How many stirrups am I using now? 40. Okay, yeah. 19, 20 on this end, times 2, 40. So again, a little bit more refined design from the first time around. I think I was using how many stirrups? 60. Now I'm down to 40. So I've cut down the number of stirrups used in this one beam by 1/3. And if I have multiple beams like this, I mean, think about the savings.